Hello, this is Marika Lamro, and this is going to be a fairly brief demonstration of how to hand calculate a one-way within subjects ANOVA. I'm going to assume that you already know how to calculate all of the between subjects ANOVA stuff. Within subjects ANOVA just has a few more steps, and I am going to talk pretty quickly through the different steps. I won't be explaining anything about the formulas. If you have any questions, if you think this video covers everything too quickly, I encourage you to view the first video that I made on hand calculating within subjects ANOVA, which has a lot more detail and goes through everything a lot more slowly. I'm showing this picture because I know a lot of people feel a lot of stress about hand calculating ANOVAs, and I think this picture is very soothing and serene, and you can picture yourself here and how nice that is, and I hope that it makes the experience of completing these hand calculations a little less stressful. Here is the sample problem, and I will give you guys a chance to read it, and when you're ready to move on, just unpause the video. So our null hypothesis is that there's not going to be any difference in how much people want to go on vacation on any of these four continents. And the alternative hypothesis is that there's going to be some difference. Here's the formula list. I'm not going to talk in any detail about the formulas in this little video. If you would like, again, to get more description of what's going on, please watch the other video I've made. This video is really intended for people who just want a pretty quick run-through of how to calculate a within subjects one-way ANOVA. So the first thing that we need to do after we calculate all of the between subjects stuff is to calculate the sum of squares people. So that looks like this for the sample. And those are the numbers for the sample. So all of this at this point is known, and we can calculate the sum of squares error. So our sum of squares error is going to be the sum of squares within, which is the same sum of squares as from a between samples ANOVA, minus the number we just calculated for our sum of squares people. Our degrees of freedom error is pretty straightforward. And once we have sum of squares and degrees of freedom, we can calculate a mean square error. So our mean square error is 3.18. And now that we have our mean square error, we can calculate the actual f value, because f is equal to mean square between over mean square error. And for this data set, that ends up equaling 2.53. We can also calculate eta squared, and for this data set, that ends up equaling 0.39. And now here we are back at the F table, which is where we always end up at the end of our calculations. We know our degrees of freedom for the numerator and denominator, so that puts us here in the table, and if you put your fingers together, you end up at an F critical value of 3.86. So here are our F crit and F calc values. We know that our F critical value is larger than our F calculated value, which means our F calculated value does not fall in the critical region of for the F table. So we fail to reject the null, and we find that there's no difference in how much people want to go on vacation in the different places. Here's all the other information that we need to write up our APA style report. And this is what a sentence would look like. And that is how you calculate a one-way within subjects ANOVA.